I chose a section Lost in the Cosmos because I am interested in space, and I enjoyed how Bryson described the vastness of space. Before reading this book, I did not have as good of an understanding of how vast space truly is. The story of everything that exists begins with creating a universe. So one way to create a universe is to shrink a proton and add some matter. But a more complex way, and the way our universe was likely created, was through the Big Bang. There's a consensus that the Big Bang happened 13.7 billion years ago, and it came from a singularity, which is a dimensionless compact spot of matter. In the first second after the Big Bang, gravity and all laws that govern physics were produced, and in less than a minute, the universe was a million billion miles across. In less than 3 minutes, or about 3 minutes, 98% of all matter is produced, and this was hydrogen, helium, and lithium, the lighter elements, and the heat created from the Big Bang enabled nuclear reactions to occur. There are other notions and theories on how the universe expanded and separated besides the Big Bang. One is that the singularity came from a collapsed universe, and there's an internal cycle of expanding and collapsing universes. Some others are a false vacuum, a scalar field, and vacuum energy, and all of these theories introduce some instability into the nothingness that was there. Another component of the expansion of the universe is described through the inflation theory, and it describes the early moments of the universe in which drastic expanding took place. The universe doubled in size every 10 to the negative 34 seconds, so obviously not a lot of time. And this theory explains the ripples and eddies that make the universe possible. Without this theory, there would be no explanation for the clumps of matter, there would be no explanation for stars, and what would be is just gas drifting in darkness. In a single instant, a universe at least 100 billion light years across was created. A successful Big Bang. If gravity and the rate of expansion differed, stable elements may have never formed, and the stable elements on the periodic table to the right are highlighted in blue, so we would have most of the elements that are completely necessary for life. And if gravity was too strong, the universe would have collapsed. If it was too weak, small particles would have never coalesce into bigger groups of particles and eventually planets. And the idea is that there was an eventual success of a Big Bang, and there were trillions and trillions of fails, and eventually one was bound to be successful. The next topic that Bryson brings up in this section is about the edge of the universe, which is impossible to visit as it would take too long, and even if it didn't take too long, you'd arrive at the point of departure, and this is because space curves in a way that is boundless and finite. One of the most important things in this section is that space is vast and uneventful. All visible things in our solar system take up less than a trillionth of the available space. Maps of Earth and our universe are never drawn to scale. If Earth was the size of a pea, Jupiter would be over 8,000 feet away, and Pluto would be a mile and a half distant, and the size of a bacterium, so not even visible to the human eye. Even though space is so vast, there is a chance for advanced extraterrestrial life on the trillions and trillions of planets that exist. One man that tried to quantify the number of advanced civilizations was Frank Drake, and he did this through a series of diminishing probabilities, and even with the most conservative inputs, he calculated that there were millions of advanced civilizations in the Milky Way, and the average distance between these civilizations is 200 light years, so distances we cannot travel, and it is likely that these other civilizations could not travel either. At even greater distances, supernovae occur, and they occur when a giant star collapses and then explodes. Fritz Zwicky thought that if a star collapsed to the sort of densities found in the core of atoms, the result would be an unimaginably compacted core, and that atoms in this core would literally be crushed together, their electrons forced into the nucleus, and this would form neutrons, and thus a neutron star. The huge amount of energy left over from the collapsing star would produce the biggest bang in the universe, which is a supernova. Some supernovae become black holes, and this is when the star becomes so dense that light cannot escape. Supernovae are rare occurrences, and this is why they're hard to spot, because stars can burn for billions of years, they only die once, and few become a supernova. Earlier in this video I stated that the Big Bang produced 98% of all matter, and this matter consisted of the elements hydrogen, helium, and lithium, yet life and our planets needed more elements in order to come into existence, like carbon, iron, among many, many others, and they would come into existence through a supernova. And the supernova would generate heavier elements through nucleosynthesis. The new elements would be sprayed into the cosmos and would form gaseous clouds, which is the interstellar medium that would eventually coalesce into solar systems. Now that we know how the elements necessary to produce a solar system were created, we can talk about how our solar system formed. This occurred 4.6 billion years ago as gas and dust accumulated. 99% of the mass went to the sun. 2 grains formed the Earth. And as these clumps of grains got larger and larger, they formed planetesimals. And these planetesimals eventually formed planets. Not long after the process to create Earth started at 4.5 billion years ago, a Mars-sized object collided with Earth, and it blew off enough material to create the moon. Most lunar material is thought to have come from Earth's crust. That's why there is a small amount of iron in the lunar material, and there's more iron on the surface of Earth. The final takeaway from this presentation, and the most interesting point to me, is that space is unimaginably vast. Pluto is 1/50,000th of the way to the edge of our solar system. Our sun would look like a mere star on the surface of Pluto. Some things that lie beyond Pluto have overwhelming evidence for their existence, but are largely hypothetical. Space can be the new frontier.